A used car dealer says that the mean price of used cars sold in the last 12 months is 21,475. You suspect this claim is incorrect. We find a random sample of 16 used cars that sold in the last 12 months, and it has a mean price of 23,399 with the standard deviation of 2,575. Customers think that it is higher than 21,475. Is there enough evidence to reject the customer's claim? We're going to use a significance level of 0.05. Assume that the population is normally distributed. We're going to round all answers to 4 decimal places where possible. So in this question, we need to test the customer's claim, and we're talking about means here, so we're going to do a hypothesis test on the means. Now, historically, it says that our mean, let me get my pen here. Historically, it says that the mean is 21,475. So that's what we're going to put here. Now, customers, here's the historical values. Customers are challenging this, and they are saying that they think it's higher than 21,475. So when we use this drop-down menu to set up the alternative hypothesis, we're going to use the greater than symbol, and we're going to say that we think it's greater than 21,475. Now, because we are not given the population standard deviation, we're only given the standard deviation based on the sample of 16 used cars. That standard deviation is right here. So we have a mean from the sample, and then we have the standard deviation from the sample. We are not given the population standard deviation. So that means we are going to run a t-test, and we're going to use the student t-distribution. Now, because we are looking to see if it's greater than 21,475, this is going to be a right-tailed test because we're going to be looking to the right of the mean where it's bigger than the mean. And we're using an alpha level of 0.05. Okay, so let's run our t-test. So I'm going to go to Stat. I'm going to arrow over to Test. And then I'm going to come down here and go to t-test and hit Enter. Since we're not given a list of data values, we're given the statistics in the problem, we're going to use the Stats option. And then I'm going to come down and put in our value for the mean. Our historical value is 21,475. This is asking for the sample from the mean, the X bar, and that is 23,999. 23 and then 399. This SX is the sample from the standard deviation from the sample, so that's 2,575. Our sample size is, let's see, 16 used cars. So we're going to put in 16 here for our sample size. And since we're doing a right-tailed test, we're doing greater than. So I'm going to choose this option here, hit Enter. I'm going to come down and hit Calculate. Now, the very first value that is given to me under here, that's our test statistic. Since we are using the t-distribution with the t-test, I'm going to choose on my drop-down menu here, I'm going to choose t. And then my test statistic is going to be 2.9, let's see, that's going to be 89 because we got to round it to 4 places, and that's 7. Oh wait, 1, 2, 3, 4, 2, 9. Nope, my bad. I didn't go out far enough. It's 2.9887. Okay, now our p-value is the second one down, and this is representing a probability, so make sure that you're listing a number between 0 and 1. So my p-value here rounded to 4 decimal places is going to be 0.0046. This 9 here is going to make that 5 round up to a 6. Okay, now let's see, when we find our critical value, because we're using the t-distribution, I'm going to use inverse t to find my critical value. So that's our next step here, is we need to find our rejection region. So the t-distribution looks pretty similar to the normal distribution. It just has fatter wings. And we're doing a right tail test, so we're going to be looking on this side of the graph. So here is my mean in the center. That's our 0. Now, our alpha level of significance is 0.05. So that means in my right tail, since we're looking at the right tail, I want that to have an area of 0.05 or 5%. So this area right here is going to be 0.05. So we need to find this cutoff point using inverse t. So I'm going to hit second distribution. I'm going to go down to inverse t. Now, if you don't have inverse t on your calculator, you can use your tables. Okay, so I'm going to hit enter. The area is going to be 0.05. My degrees of freedom, since our sample size in this case was 16 cars, right? Degrees of freedom is always one less than that. So I'm going to put in degrees of freedom of 15. And then I'm going to paste. Now this is going to give me a negative number because 0.05 to the left is going to really be looking over here on the left tail. But since this is symmetric, I'm just going to choose the positive value since we're looking to the right of 0. Okay, so our t critical is going to be positive 1.7531. And I'm making this positive because we're looking at the right side of the graph. Remember, on the right side, we're looking at positive values. On the left side, we're looking at negative values. So my t critical is going to be 1.7531. So that's what's going to go in here. I'm going to choose t because we're doing t distribution. And then I'm going to put in positive 1.7531. Now, if this was a left-tailed test and we were looking at the left side, I would definitely keep that negative in there. Okay, now using our test statistic. Our test statistic here, our t, is 2.9887. That falls on this side of our critical value. It's 2.9887 is greater than 1.7531, so it's on this side. So our test statistic falls in the rejection region. So that tells us that we need to reject the null hypothesis. Now, if it fell in the white area and it fell to the left of my critical value, then we would say do not reject or fail to reject. But because it falls in that red area, we're going to reject. So I'm going to choose this option here. Now, it says compare the p-value to alpha. Our p-value is 0.0046. And that is less than our alpha, which is 0.05. And whenever our p-value is less than our alpha, we say reject HO. All right, so these should always come out the same, step 3 and step 4. We're doing this 2 different ways to check ourselves. If they don't come out the same, something went wrong. Now, because we're rejecting the null hypothesis, what we're saying is there is enough evidence to suggest that this alternative hypothesis could be true. So when we answer this, we're going to say that there is sufficient evidence to support that the mean price of used cars sold in the last 12 months could be higher than $21,475. So we're going to choose this one. The only difference between these two is that there is or there is not sufficient evidence. When we reject the null hypothesis, we're saying that there is enough evidence to show that that alternative hypothesis could be true. Okay, so then we're going to check that one. So this is our conclusion here.